Hello everyone, my name is Austin Rovinsky, and I'm an assistant professor at New York University. This is the 12th lecture in my mini course on physical design databases, and this lecture will introduce you to scripting with Tcl and Python. In particular, I'll go over an example of how to access OpenDB using the automatically generated ODB Swig interface. Okay, so I have the previous example design that we've worked on pulled up. This is the GCD design, so you can see in the OpenRoad GUI that we have all of the routing. This design is done. It's already run through the flow. And so this design being loaded up, now we're going to actually go into this bottom window here, and you can see that this is the scripting window in the GUI. You could, of course, use the OpenRoad shell without the GUI, but I figured that this would be just a good example to show you how you can use this. So we're actually going to do a repeat of the C++ program that we did, because as you saw in the C++ program that we wrote, it was using the OpenDB APIs in order to get information that it needed to return the instance count of the design. So here, what we're going to do is the exact same thing, but because all of the OpenDB interfaces have been automatically translated into Tcl commands through the Swig generator, we can just use those directly in Tcl to also get the same result. So the first thing that we're going to do here, and you can see in this bottom window, there's a helpful auto-completion that can auto-complete commands for you, is that we're going to do this getDB command. And the first thing that that will do is it will, you can see, return this string, which is actually a text version of the pointer. So this getDB command returned a pointer. And so in Tcl, we're going to save that to a variable. So we're going to set db, so that's creating a new variable db. And here we're just going to do that same command that we did, so get db. And so now these brackets mean that it's executing the command, and then it's taking the result of that, and then it's going to save it to this variable db. So you can see that the result is the same, but now if we use puts, which is printing a string, and then we take that $db variable, we can see that it's now saved in the variable. So now that we have our db, we can actually do this nifty trick where we actually call the variable directly, and now we can use a function on that object. So we can see right away that even getChip from this db is already recommended. So we have that, and now we can save this to a variable, very much similar to what we did in C++. So we can set the chip, and now we can see that there's a chip pointer that's saved there, and now we can get the block from that. So we can do the chip, and then get block. So we can execute that command and then save it in a block variable. And now we're almost there. Now we can just do set insts, and then we can execute this command block is going to get insts there. So remember, in C++ land, we were using these functions. These were inside the OpenDB header file, and all of these have been automatically translated to Tcl. So we're just running these functions, and now you can see that there's a whole big list, and it actually has this these ellipses to say that there's a lot of pointers that are being created here. And you can see it's a whole list of db inst pointers. And now we can just use some Tcl built-in commands. So we have this length Tcl built-in command, which is getting the length of a list, because this is a Tcl list that has been returned. And we can do that on the insts variable. And we can see that for this design, and perhaps this may or may not have changed from the previous time this was run because I reran this design in the background, but we can see that we have 974 insts. So that's a way that we were able to just use plain Tcl. This is unmodified OpenRoad. We didn't have to modify any C++, add any tools or anything. We just directly grabbed Tcl commands and used the internal OpenDB functions in order to get this metric. So why would you want to do something in C++, considering that you could do something in Tcl and you don't have to recompile, don't have to do any of that? Well, the reason is because if you do something in C++, not only do you get more intimate access to some of these structures, not everything is going to be accessible from the Tcl shell, but also it's going to be much higher performance. So if you need to do something that's a very expensive operation, lots of computation, it's going to be a lot more efficient to do that in a compiled language in the C++ than it is to do it in Tcl, which is this interpreted language, and it's going to run a little bit slower. So next I'm going to show the same example, but we're going to do it in Python instead. Unfortunately, Python is not quite as well supported as Tcl is, so we can't access it through the GUI at this moment, but we can at least still create Python scripts and then use OpenRoad to execute those. OpenRoad has both integrated Python shell and Tcl shell, which is the primary way to run this. You should run the OpenRoad executable and use the shell there rather than trying to run a Python shell and then import OpenRoad. That may exist in the future, but at least right now the best support is to run OpenRoad first and then use that shell. So I want to show you, I'm just at my terminal and I'm inside the OpenRoad flow scripts folder and inside flow, and I've created this file, this script file inst count, and we'll open that up and take a look at it. So we can see the first thing that has to be done here is I'm importing what I need from OpenRoad. So from OpenRoad, import tech and design. So these are specific classes for Python that make it easier to access the underlying data structures. So this is a little bit of boilerplate that we didn't have to do for Tcl. Fortunately, like the makefile can alleviate some of those burdens. But the first thing that we are going to need to do is we need to create the tech object, and then we're going to read the liberty, read the left files. So this is directly from the NANDGATE platform, because the design that we're going to be loading in the next step here, and we're reading the def, is the output of the flow. So this is the 6_final.def. So this is the end output of the flow. And so once the left file is read, once the def file is read, then the design has been loaded. And so we can then do our Python commands to access things in the design. So the first thing that we're going to be doing is trying to get access to the DB. So the way to do that is from the design that we loaded, we'll get the tech object, and we'll set that to a variable. And then we'll get DB from there. So this will give us a Python object, which is linked to the ODB. And then from there, then we can do the same commands that you've seen both in C++ and Tcl now, where we can get the chip, set that to a chip variable, get the block, set that to a block variable, and get the list of instances. And then the last thing that we'll do is we'll just print out the instance count, and we'll use the built-in Python function, because inst is automatically mapped to a Python list. So we just use the len, the for length function in Python on those insts. And so if we go ahead and exit out of this and then run that in OpenRoad, so I've already set up my environment. So if I just invoke OpenRoad, I'll use the -python flag so that OpenRoad knows to use and execute using the Python interactive shell. And then I will use the inst count script, and I'll just go ahead and run that, and everything starts up. And you can see all the normal commands that you'd see if you were running these commands from OpenRoad flow scripts. You can see that's reading the def file. It created the design, finished it. Those other commands, there's no visible printing that happens until we print out our final message and we see instance count 974. So this is an example of the same thing that we just saw in Tcl. The same program that we've written in C++ can also be done in Python. Not quite as well supported, unfortunately, as Tcl right now, but there is a lot of support, especially if you want to access the base ODB functions in order to manipulate them. And of course, you can import any kinds of functions or any other packages that you want in Python to make things easy. If you want to do some sort of data analysis, if you want to do some sort of machine learning, you can use these Python scripts and these interfaces in order to bring those in and make it easier to work with. All right, well, that's all for this time. I'd like to thank Nordtech, who sponsored this video series and has made this possible. And I'd like to thank you for taking the time to watch it. I'll see you next time.